Hello and welcome to another problem solving session with Special Maths Academy. And in this video, we'll be looking at one of the questions from the third round of the South African Mathematics Olympiad, senior category of 2021. So let's go straight into the question. Let PAB and PBC be two similar right-angled triangles in the same plane with angle PAB equals to angle PBC equals to 90 degrees, such that A and C lie on opposite sides of the line PB. If PC equals AC, calculate the ratio PA over AB. Okay, PA divided by AB. So let's sketch. So these two right angle triangles are similar. They share a common side, PB. Given that the angle at A in triangle PAB is equals to the angle at B in triangle PBC equals 90 degrees. But this condition alone is not enough for us to know the orientation of the similarity. So we'll consider two cases. So the first case, first of all, let angle BPC be alpha. So the first case is if the orientation of similarity is in this fashion, that is the angle at B in triangle PAB is alpha. What does that give us? We have that sum of angles in a triangle is 180 degrees. So this gives us that the angle at C in triangle PBC is 90 minus alpha. Okay, and this angle is also 90 minus alpha. Okay, but then what do we have? 90 minus alpha plus alpha is equal to 90 degrees. So that this angle here at P is 90 degrees. So we have something like this. PAC, the angle at P 90 degrees. But we want PC to be equals to AC. But this is a contradiction because we know that the hypotenuse of a right angle triangle must be greater than all the other sides. Okay, so this implies that the orientation of similarity must be the other way. So we must have that this angle here is alpha as well. Okay. So let's erase this. So now if the orientation of similarity is this way, what can we get? So let's let PB be equals to, or rather you can say let PC be equals to X. Okay, so what does this imply? This implies that sine alpha is equals to BC over PC. So from right angle triangle PBC. So since PC is equals to X, so this is equals to BC over X. So we have BC is equals to X sine alpha. Okay, so very important. And then let's find PD. So to find PB, we can use cosine alpha. Cosine alpha is equals to adjacent, the adjacent to the angle, so that's PB over the hypotenuse, PC. So remember, we're still dealing with triangle PBC. Okay, so we had that PB, PC is equal to X, so this gives us that cosine alpha is equal to PB over X. So we have PB equals to X cosine alpha. Next, we find AB. So let's find AB. So from triangle PAB, sine alpha is equals to opposite, which is AB, over hypotenuse, which is PB. So from triangle PAB, so PB, remember that PB is equals to X cosine alpha. So I have sine alpha is equals to AB over X cosine alpha. And so we have that AB is equals to X sine alpha cosine alpha. Okay. Okay, now. So recall that PC is equals to AC. Okay. So recall PC is equals to AC. And recall that angle ABP is equals to 90 minus alpha. Okay, so from triangle ABC, we have 90 plus 90 minus alpha. This angle here, B, is going to be equal to 180 minus alpha. Okay, so how that AC squared is equal to, so by cosine rule, AC squared is equals to AB squared plus BC squared minus 2AB times BC times cosine 180 minus alpha. So recall that PC is equals to AC, so we just put X because we already said PC equals X. So X squared equals AB squared. What is AB squared? AB squared is X into sine alpha cosine alpha squared plus BC squared. BC is X sine alpha, so just put X sine alpha minus 2 into AB is going to be X sine alpha cosine alpha, and BC is going to be X sine alpha, and cosine 180 minus alpha becomes negative cosine alpha. Okay, so we can see that the X squared will cancel out, X times X. Okay, so here we have 1 equals to sine squared alpha cosine squared alpha plus sine squared alpha minus, so because of negative cosine alpha in the last bracket here, this minus will become plus. And so have plus 2. Here we have sine alpha times sine alpha, so plus 2 sine squared alpha. And then we have cosine alpha times cosine alpha, so cosine squared alpha here again. Okay. So we have 1 equals to, so we can factor out sine squared alpha. Okay, so on that technique we can use this. We can just take this here. So we have 1 minus sine squared alpha. So basically taking this to the other side equals to, and then we can factor cosine squared alpha here. Cosine squared alpha into sine squared alpha. So into sine squared alpha plus 2 sine squared alpha. Okay, so 1 minus cosine squared alpha is cosine squared alpha equals to cosine squared alpha. And so let me just put this is 3 sine squared alpha. Okay, so I have cosine squared alpha into 1 minus 3 sine squared alpha equals to 0. Okay, so I have two possibilities: either cosine alpha is equals to 0 or sine alpha equals to 1 over root 3. Now, why didn't I say plus or minus 1 over root 3? Because alpha is an angle in a triangle, and sine of alpha is positive from 0 to 180 degrees. So there's no need of considering negative 1 over root 3. So now if cosine alpha is equals to 0, that's this will imply, the first case will imply that alpha is equals to 90 degrees. If alpha is 90 degrees, then we see that we have a degenerate triangle, because we will have two angles in a triangle being 90 degrees. So I have this angle here being 90 degrees, as well as this angle being 90 degrees. Okay, so I have a degenerate triangle. So it means we don't consider this case. So we consider the case. So it means what we have is sine alpha equals to 1 over root 3. Now, what are we looking for? PA over AB. So PA over AB. So that is tan alpha is equals to, so from triangle, looking at triangle PAB, tan alpha is equals to opposite, that is AB over adjacent, which is PA. So this implies PA over AB is equals to 1 over tan alpha. So to find tan alpha from this, we can quickly get, so can just sketch a diagram and get our angles immediately. So if we say this is a triangle with alpha here, and we say let this be 1 and this be root 3. Okay, so opposite of alpha is 1 and the hypotenuse is root 3. So it means the other side from Pythagoras theorem can be gotten, and this would be root 2. Okay, so it means tan alpha is opposite of adjacent, which is equals to 1 over root 3, which is equals to root 2. Okay, so the ratio PA over AB is equals to root 2. Okay, so that'll be all for this video. I hope you enjoyed the video and learned one or two things. So don't forget to share, like, and subscribe. See you guys in the next video. Goodbye.